Hello everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. So in today's class, we are going to have the same topic, which is eigenvalue and eigenvector. We are going to have a special case. Already we done one special case in the last class. Today also we are going to continue the special case problems. Okay, this is the problem. Today we are going to solve. So find the eigenvalues and eigenvectors of the matrix. This is the matrix. Okay. Then if you see this matrix, actually this matrix is what? Symmetric matrix, right? So under symmetric matrix, we are going to solve this problem. So the first thing is we need to find demon. You already know the concept. Using the formula, you need to find the value, which is 0. And d2 wise, just find the sum of minus of the main diagonal. So the answer is minus 3. And d3 is, yes, we need to find the determinant of this matrix. So the answer is minus 2. Okay, so we got d1, d2, d3. We just substitute in the characteristic equation for 3 cross 3 matrix. So finally we are going to get the equation which is in the form lambda cube minus 3 lambda plus 2 equal to 0. Okay, now we need to solve this equation. Either you can use the calculator or you can use synthetic division. Using synthetic division, you just find the values of lambda. Okay, so the values are minus 2, 1, 1. Okay, these are the 3 values. Yes, so here the roots are repeated, right? Symmetric matrix, roots are repeated. Okay. Yes. Now we are going to start the eigenvector. The formula is what? A minus lambda I into x equal to 0. Just take the diagonal as minus lambda. Okay. In a given problem. And into capital X is what? x1, x2, x3 equal to 0, 0, 0. Now the first lambda value is minus 2. And substitute it here. So finally we are going to get the matrix which is in the form 2, 1, 1, 1, 2, minus 1, 1, minus 1, 2. Okay, hereafter we are going to check first 2 rows. So the first 2 rows is a different or same? Yes, which is different. That means not to use cross multiplication rule. After applying cross multiplication rule, we are going to get the eigenvector which is in the form minus 1, 1, 1. Okay, so one eigenvector is over. Now we are going to proceed the repeated eigenvalue. Okay, what is the case? I want to remember here. Yes, now what is lambda value? Yes, which is nothing but 1. Just replace lambda as 1 here. Finally, we are going to get the matrix which is in the form minus 1, 1, 1, 1, minus 1, minus 1, 1, minus 1, minus 1. Okay, then into x1, x2, x3, that should be equal to 0, 0, 0. Then I want to check the first 2 rows. Actually, if you see here, all the elements are equal. Yes, you can check the first row. If you multiply the first row by minus, you are going to get either third or second, right? That means all the 3 are same. You can consider any one equation. Finally, we are going to take the equation which is in the form minus x1 plus x2 plus x3, that should be equal to 0. Okay, so matrix is symmetric matrix. Roots are repeated. Equations are same. That means I ought to remember the concept. One thing I ought to take the substitution. For the second one, I ought to use the orthogonal condition. Okay. So first thing we are going to take the substitution method. For that, we can choose either any one value equal to 0. Here we are going to take the value as x1. Yes, just substitute here. So we are going to get x2 plus x3 equal to 0 and bring this x3 to the right. So x2 equal to minus x3 and we need to write in the ratio form. That means we just bring this value to the left. So we are going to take the form which is like this. Okay, finally we are going to write the matrix, the eigenvector. First write x1 value, but which is 0. Second value is minus 1 and third value is 1. So this is second eigenvector. Yes. For third eigenvector, we need to take x3 as L, M, N. Be the third eigenvalue. Okay. Sorry, third eigenvalue. And we will have the condition, orthogonal condition. Using that orthogonal condition, we are going to find the third eigenvalue. Okay. Now, what are the conditions? Yes, x1 transpose x3 equal to 0. Then x2 transpose x3 equal to 0. x1 transpose, already we got the value for x1. Just take the transpose, which is nothing but minus 1, 1, 1. And x3 is L, M, N. That should be equal to 0. Okay. Finally, we are going to get the equation which is of the form minus L plus M plus N, that should be equal to 0. And the second thing is we can take x2, x2 is this value, so 0, minus 1, 1. Then x3 is what? Same L, M, N. So So that is equal to 0. Again we need to multiply by this. Okay, finally we are going to get the equation which is of the form 0L minus M plus N. That should be equal to 0. Now we want to use cross multiplication rule. After applying cross multiplication rule, we are going to get the answer which is like, we are going to start with 1 minus 1, 1, 1, then minus 1, 0, again 1 minus 1. Okay, we can put the value L, M, N. So finally L by, what is the value? Yes, 1 plus 1 is 2, and M by, the answer is 1, and N by, again the answer is 1. So from that we are going to get x3 is what? L, M, N. That should be equal to 2, 1, 1. Okay, so this way I want to find the third eigenvector. The case is symmetric matrix, roots are repeated, the equations are same. This way I want to find the eigenvalue and eigenvector. Yes, I got the idea about this case, right? So thank you.